Okay, so these are the expressions of the volume and the surface area of revolution, and we'll use them. So whenever you are asked to do that, do this proof, right? So keep in mind what are the different conditions for the surface. I mean, for the curve and the area. Okay, for which you can define such a surface area of revolution or volume of revolution. Okay, and okay, so the next thing is we'll use these two formulae to solve certain problems. Okay, so you have this trapezoidal shaped geometry. Okay, and the dimensions have been given. So can you now find out how much would be the volume of revolution? Okay, one thing that regarding centroid, you see, there would be different geometries for which you can directly gauge the centroid. Okay, but I would suggest, except for a rectangle for which it is exactly in the middle, so like h by 2 and b by 2, and for a triangle, and not necessarily a right angle triangle, so any triangle, if you're looking for the centroid, the location of the centroid perpendicular to the base, that is 1/3 away from the base. Okay, so if this is the height, so this is h by 3. Okay, now these two you can use. Okay, in my opinion, you are not allowed to assume anything else. Okay, I mean, of course, by the time you solve a couple of problems, you might have gained some idea about what the different centroid should be. For example, what is the centroid for a semicircle? Okay, so you might know the idea, might know the expression, but I would suggest don't try to remember which is not as simple as this one. Okay, uh, yes, you can just have some confidence to be able to derive that as and when required. Okay, and by the same logic, you are not also allowed to remember the centroid of the trapezoid. Okay, I mean, uh, mm, at at best, what you can do is you can divide the trapezoid into a set of triangles and a rectangle and get the idea about the centroid. Okay, so for example, if I measure from here, if I measure the coordinate from here, let's call it x. Okay, then for the triangles, the centroid should be at a distance of 1. So the areas of the triangle, let's label the corners. So the area of, let's say, ABF is okay, and also their x bar should be equal to 1 for ABED. The area is 2 times 3, and x bar is 3 by 2 as measured from this side. Okay, so you can determine the overall location of the centroid using the compound geometry. So it is 3 by 2 times 1 times 2 plus 2 times 3 times 3 by 2 divided by 3 by 2 times 2 plus 2 times 3. Okay. So what is the value of this expression?
Sir, can I do it separately? Like I can take the upper right angle triangular shape and then the rectangular shape, and the lower
Yes,
half will be symmetrical.
yes, you can do that. Okay. So so as long as you are not skipping any step, I would think that using the formula for the triangle and the rectangle is equivalent to not skipping any step. Okay. As long as you are not skipping any step, that is good enough. Okay. So to me it looks like 1.33. Let me know if you get any other value.
So here it is rotating about the z-axis, so we have to take the y-coordinate.
Yes, I mean, yes, if you call it y-axis, then yes, of course, y-axis. So basically, you need to know the location of the centroid from one of the faces. So if you know that, let's say if I know this is to be 4 by 3, so the y bar is essentially your yeah, I should have denoted with some other coordinate, right? So let's call this as S. So this one is S bar actually. So your Y bar should be 2 plus 3, which is 5, minus 4 by 3, which is okay. So imagine the problem statements are how much the volume weighs if the density is so all you need to do is get the volume and then multiply with the density, so you have the value for the mass. তোমরা কিন্তু এখনো বলনি আমাকে যে তোমরা এই উইকের মধ্যে কবে ক্লাস টেস্ট দেবে।
Sir, 18th is fine.
Sir, 18th, sir.
18th. আচ্ছা, so today is 14th, so 18th would be Sunday, right? আর তোমরা বলেছিলে friction syllabus is not a problem, so friction can be there, right? Okay.
Sir, class test 2টায় কি থাকাবে?
Last test 2 তে বাকি যে জিনিসগুলো করানো হচ্ছে, properties of surface, and next comes your dynamics of particles.
Sir,
Yes.
sir, can you explain why you did that 5 minus 4 by 3?
5 minus 4 by 3.
I mean,
See, I took the s coordinate s from the the larger face of the trapezoid, right? Larger side of the trapezoid, not face. And you see, if you measure the distance from z axis, that larger face is at a distance of 2 plus 3, 5 inches.
oh, acha. Okay, sir, understood.
Okay.
Understood.
ভলিউমটা কি বার করা গেল?
হ্যাঁ স্যার, excellent.
Sir, volume is coming 207.34 inch cube.
Okay. 207.64 pound,
34.
right?
So 34. So that is the volume.
Oh, that's the volume, not
Yes, sir.
the mass, right? So that much.
Mass is the 23.
Okay, 23 point something, right? Okay,
Yes, sir.
I actually do not have the answer. I mean, to be frank, I came up with this density just now. Okay, so I took the idea that let's say 1 cubic centimeter of iron or steel weighs around 8 grams. So I tried to convert that actually.
Okay, sir.
Okay, maybe not correctly, but that was the idea. So around 23 pound you are saying, which is fine.
Yes, sir.
Acha,
Sir, it's pound per inch cube you are given.
yes, pound by inch cube. Okay, so I mean, maybe I didn't convert the density correctly, whatever the case may be, but that is the idea. So you may be asked to find out the mass of a given geometry, and you can use Pappus theorem to find out the volume of revolution. Acha, one more thing. If you look at the numerator of this expression, that is the one that actually we required. Okay, it's not the actual value of the centroid. Was that required? No, actually that value was required. Yeah, so that value was required, because then only you can get with respect to I mean the distance from z axis. Okay. Acha. So the next part of the question is what would be the cost of painting the surfaces or the exterior, rather the exterior of the geometry at the rate $0.25 per inch square. Quite a high price, but seems convenient.
Sir, just a bit of curiosity.
Yes.
Uh, if it had if it has said that the cost of painting both the exterior and the interior, exterior could be found out by this only. If it
Mhm.
asks for interior, then we would have taken as rectangle with one of the side on the z-axis, and it would have means we would have used the formula for that for the surface area, right?
No, I don't understand what you are saying. First of all, there is in this problem at least there is no interior. But imagine if this was hollow, then indeed there would be an interior. Okay, actually I'm
No,
sharing
sir,
the.
not that interior. Means
Okay.
if it had made a 2 pi round, then that interior won't be accessible. I was saying that means from the z-axis to the solid, means that 2 inches that difference, that one,
Okay. Okay.
that interior I was saying, sir. Yes, sir.
So this surface.
Yes, sir.
Okay,
Yes, sir.
see the exterior. Basically, I'm talking about all the surfaces. Let's say this one, and actually it was a trick question, but I was also talking about this 4 and 5, all the faces. I mean, the entire exterior of the geometry. By exterior, I meant that all the surfaces. So not only the surface area of revolution. So because it's not a full circle, you'd encounter this, faces marking the two ends, the beginning and the end of revolution. Okay, so actually this was a trick question. Uh, mm, Now it is not. So it was meant to be that some of you might might not include these two flat surfaces along with the surface area of revolution.
So then for 4 and 5, we have to know that by what angle theta it has rotated.
Yeah, it is quite obvious, right? You see, these are the lines that I didn't draw. Okay, so basically it's a 180-degree rotation. This rotation is 180
Oh,
degrees.
oh, okay, sir, okay, sir.
Okay, so basically if this is y-axis, then this is negative y-axis.
Oh, okay, sir, okay, sir.
Sir, I am
Yes.
just asking about the image. Sir, suppose if the question is given in the exam, then should I have to draw the images? Like this 3D image is very much difficult to draw in the paper.
Mhm. It is
So,
not the
sir,
most difficult image, but the thing is, I don't think you need to draw this. Okay, unless you want to, clarify something. Unless you want to use, uh, you need to draw an image. Unless you need to draw an image to explain your idea. Okay, so imagine if it is, a slightly complicated problem where you need to do some manipulation. Okay, for example, here I drew this trapezoid. Okay, and I'm not talking about the 3D geometry, but this trapezoid I drew because I wanted to take this coordinate from this face or this side of the trapezoid. See, this coordinate A is from CD. Okay, so that I cannot simply assume that the examiner would know. Okay, whenever you are trying to do something on your own that is not being, a part of the question, so whatever is additional, so you need to do that on your own. I mean, for that you need to explain that with the aid of an image. Okay, so if you imagine you do something related to the volume of revolution which requires certain other type of manipulation, okay, then probably you should draw the image. If not required, then don't. Okay, so did you get the surface area of revolution? So it's a pi rotation times the total length. So total length over here, this is 4 inches. On this side, it is 2 inches. And for these two, it is square root of 3 squared plus 1. So the total length is 4 plus 2 plus 2 root 10. So how much did you get for area of revolution?
The exterior area is coming 201.06 square.
Okay. Acha, so A exterior would be A revolution plus twice into 3 times so 4 plus 2 by 2, so 3 again. Okay, so basically the area of the trapezoid. So that is the total area. Okay, so basically you need to add the area of the trapezoid twice. So this is the area of the trapezoid. Now how much is your area of revolution?
You mean the area, the part 1?
No, I mean how much is your area of revolution, this quantity?
Actually, I have done that the inner cylinder plus exterior cylinder plus that sloping twice of the sloping area.
So you have taken the inner cylinder, the
Yes, sir.
outer cylinder, and then
Yes, sir. And then the area of the sloping circular thing. Yes, that one.
okay.
One.
So how
Twice
did
of
you
that.
determine the area of these faces?
Sir, actually, I took along the z-axis. I took circles which are z-axis as the perpendicular to the circles which uh, if we move like basically we are revolving that straight line along around the z-axis.
Along the z-axis. Okay.
Yes.
So where would be the centroid of that straight line?
Basically our
So did you use Pappus theorem or not?
no, sir, actually I integrated by using differential regions like that.
Okay. I mean, that you can always do. Okay. But what is the purpose of discussing all that? The surface area of revolution or volume of revolution using Pappus theorem. I mean, for this entire boundary of the trapezoid, I can determine the centroid, right?
Yes, sir.
Or rather, I can use the Pappus theorem. Has anyone solved it with using Pappus theorem? Has anyone got the area of revolution using Pappus theorem? Okay, right now you can calculate using Pappus theorem, right? So what would be the area of revolution? You have the value of L given over here, then pi and then y bar. So how much is the area of revolution? কেউ কি করনি বা কেউ কি করতে পারছো না, বুঝতে পারছো না আমি কি বলছি?
Sir, it is becoming some difficulties using the Pappus theorem. That's why we
Why?
are using.
You don't talk for everyone else. You can say for yourself. But my question is, why is it difficult to use Pappus theorem? What is the difficulty? Difficult কেন বলছো বলো?
Sir, we have calculated the S bar for the area center. And why we are using the Y bar as the same for the calculating area of the revolution?
I never asked
we
you
have
to use. Okay, let me finish. I never asked you to use the same y bar. I didn't say that the y bar would be the same. Okay, you'll have to calculate the y bar again, and that's actually the other part of the trick question. That I mean, I would assume that you'd get the area of revolution by using this y bar right here. But even if you are required to get the y bar for the boundary itself or the line, okay, can you not get the y bar? I'm not asking you to use this y bar right here. That would be wrong because this is for the area.
Yes, sir. From them, I was confused between these Y bars only because I confused that why the same Y bar is used.
No, same y bar need not be used. The y bar.
Yes, and now it is clear. Now it is clear.
Okay, so for example, where lies the centroid of these two sides? I mean, for these two sides, it is obvious that they are at the respective y locations. Okay, so for this one, it is 2 inches. For this one, it is from z-axis, it is 5 inches. But what about these two oblique lines, non-parallel lines of the trapezoid? Where does the centroid lie for that one? You see, it has to lie in the middle of the line, right? If it is a straight line, then it is exactly in the middle. And if I join these two midpoints, isn't that line supposed to be parallel to these two parallel lines? Or basically, that line would be basically at a distance of 2 plus 1.5, that is 3.5 inches from z-axis. So the y bar in the case of the lines is going to be how much? It is going to be 2 times 2 plus 4 times 5 plus 2 root 10 times 3.5, that divided by 2 plus 4 plus 2 root 10. That's it. So can you tell me what is the value of this y bar?
Sir, it is coming 3.74.
Okay. Then you can get the area of revolution using this L right here, this y bar right here, and pi. What value are you getting for area of revolution?
Sir, it is coming 144.94.
That seems too little. 144.9 or 145 inch squared.
Yes, sir, it is coming like this.
Okay. Maybe.
Sir, I'm rechecking the calculation.
Yeah, it seems correct to me too. About 145 inch squared. Okay, so from that
Sir,
you can
the cost is coming 40.725 rupees.
okay. So basically, when you added 18 from here, it was
So it was 162.9.
okay. So 163, and
And
then you are dividing
yes,
it
sir.
4. So
Yes, sir.
okay, so I think this can be done. So now we will look into a few more problems. Okay, so again, the question is to get the volume of revolution and the total area, which is the area of revolution, plus if I call this area as a star, twice a star. Okay, so then the volume of revolution is pi, uh, again y bar a star, right? So can you tell me how we can get the y bar in the two different cases? So actually we can call them y bar 1 and y bar 2. So this y bar is the area average and this y bar is the line average.
Sir,
Yes.
sir, can you give some description of the body? I cannot get it. How the body is oriented.
Okay.
The figure is quite confusing.
Imagine there was a rectangle and then you took away a semicircle. Okay. So that would be the area that you are revolving about the axis. And when you do revolve that about the axis,
Sir, this is a cross section of that.
yes,
That means there is no gap between the zx plane and that body, means that rectangular cross section.
zx plane. Acha. First of all, let's say this axis is y axis.
Then zy plane.
Zy plane, yes. These faces are lying on the zy plane.
On the z plane, there is no difference, means there is no gap.
Yes.
Okay.
So for the cross section, you can think of it as a rectangle, okay, being made composite with a semicircle, okay, and try to get for this one what is the, for this section, what is the centroid of the area and the centroid of the boundaries. I mean, of course, for the rectangle, the centroid is at a distance of how much? 60, 160 minus 60. So at a distance of, from this face, okay, at a distance of 50. Okay. And for, so this I'm talking about the centroid of the area. Now for the circle, you'll have to take differential area like this r d theta dr, where theta ranges from 0 to pi. uh, you know, from, we are talking about this angle right here. theta. So that goes from 0 to pi, and let's say this angle is d theta. Okay. And r r d theta is one of the dimensions, and if I take this much to be r and this much to be dr, so this dr and d theta makes up for this differential area. Okay. And you are taking r sine theta as the y coordinate, and then r ranges from 0 to 60. Okay. So all you need in this case to get volume of revolution, a star times y bar, which is a summation of ai yi bar, which is the area of the rectangle is 200 times 100, right, millimeter squared, times 50 is the distance of the centroid. And since the circle is negative, so I mean, by doing this integration, you would get a y bar, a to y, a y bar for the circle. You will be doing a y bar for the circle. Okay. So whatever that is, substitute over here. A circle, y circle. Substitute it over here, and then you have for this entire cross section how much is a y bar. Okay. So did you get the volume of revolution? এটা পারা যাচ্ছে ভলিউম অফ রেভলিউশন?
হ্যাঁ স্যার করছি, জাস্ট একটু।
So for the circle or semicircle, a y bar is let's say 0 to r0, 0 to pi sine theta d theta r squared dr. So this can be written as r0 cube divided by 3 times, now sine theta d theta between 0 to pi is simply 2, because 0 to pi by 2 it is 1, so 0 to pi it is simply twice of that. Okay. So the area under the curve is simply twice of that. Okay. And then the area is pi r squared divided by 2. So y bar for the semicircle would be r0 times 4 divided by 3 pi. That's what it seems to me.
Sir, I am getting 5.39 into 10 to the power 6 millimeter cube.
Okay. Okay. So that is the volume of revolution.
Yes sir, yes sir.
Okay. Okay. Now try the area of revolution. Now to get the area of revolution, you need the centroid of the all the boundaries. Okay. So let's say so you need to split the boundary into different, you know, line segments. So there is like 1, 2, 3, 4, 5, and finally 6. So for 1 and 2, the total length is 20. So it is 200. So 40 plus 40, 80. So 40. So L times y bar would be 40. So to get sorry, L times y2 bar would be 40 times 2 times this distance is 60 plus 160 times 200 plus, for these two edges, these two horizontal edges, which are of length 100 millimeters, so 2 times 100 times 50 plus 60, that is 110. And then for the y bar for the circular arc.
So what was the volume, sir?
Volume of revolution.
Yes, sir.
Somebody who said the volume of revolution? I
Sir,
don't know.
it was 5.39 into 10 to the power 6.
10 to the power 6
5.
millimeter cube.
Yes sir.
Okay.
So I'm getting 12.91.
Okay. So
Is the order 10 to the power 6?
Yes. Millimeter cube.
okay, you are getting 12.69,
12.91.
12.91.
So once again, I am checking for any calculation mistake.
Okay, so can you get the a y bar would be 2 by 3 times 60 cube, okay, for the circle. So you have 100 times 200 times 50 minus 60 cube is times 2. So this, okay, so this is the a times y bar. So this is 10 to the power 6 minus this. So it is going to be a star time y bar 1 is 856
So 0.856 into 10 power 6.
10 to the this much 10 to the power 3, and then when you multiply with pi, um, it is going to be quite a different value if you multiply with pi. So in my opinion, it is around 2.2.7 into 10 to the power 6 or something millimeter cube. Achha, one mistake that I made was that this is not okay. So this you see I took this one, this distance to be 50, right? This distance to be 50. So what you need to do is you need to additionally, in addition to this, you need to add how much is this? 200 times 100 and minus pi by 2 times 60 squared. This area, this times 60. That is this distance. Just to take the distance from z axis. So with that, you will have your a times y1 bar as measured from z axis. So 200 times 100 minus pi by 2 times 60 squared times 60. So with that, what value are you getting for a star times y1 bar? So this is the a star times y1 bar when you take the distance, from this vertical line right here. But if you want to take it from z axis, you need to add 60 additional to the term y1 bar. But to do that to a star times y1 bar, you need to multiply with a star, which is basically this quantity, 200 times 100 minus pi by 2 times 60 squared.
Sir,
Yes.
when you said surface area, that means the outer surface area and the inner hollow surface area, right?
No. I mean, this is not a hollow geometry. This is a solid geometry. So basically, all you need to do is the total surface area is the area of revolution. That means when you revolve this geometry right here, okay, plus twice of this geometry. So you take the boundary, revolve that, take the inner geometry, multiply with 2 and add that. So twice A star plus, you see this whole
Oh, okay.
boundary is L. So do the area of revolution for L.
Oh, sir, that means for the volume also, then we have to take for 180 degree rotation.
Yes.
Oh, sir, then it's fine. Sir, then it's okay. Then it's okay, sir. Sorry, sir. My mistake it was. Then it's okay, sir.
Okay. Now, can you tell me how much are you getting for A star Y1 bar when you do this correction? কত আসছে এই কোয়ান্টিটিটা? এটা একটু চেক করে বলো না কত আসছে। 8 এটার সঙ্গে যদি আমি অ্যাডিশনালি এই টার্মটা যোগ করি,
Sir, I am getting 1.71688 into 10 to the power 6. 1.71688 into 10 to the power 6.
10 to the power 6.
Yes.
And if you multiply pi with that,
It is coming approximately 5.391 into 10 to the power 6.
okay, so the original answer, right? So
Yes, sir, I am also getting that, sir. I did a mistake, sir.
okay, okay. Acha. So now when we are talking about okay, L times Y2 bar, that is this part of the area of revolution. So for that you need to do that for each segment. So we have already done that for 1, 2, 3, 4 and 5. For 6 we need to take the length of the circular arc, and the length of the circular arc is simply pi times r0, r0 being 60 millimeters, and then we need to get the y bar for the circular arc. So to do that, please note that if this is the differential length dl, that dl is and if this is the angle theta and this is the angle d theta, so so dl is simply r0 d theta, and we are trying to get y bar. So integration r0 d theta, okay, and multiply to that r0 sine theta for the y coordinate, and then integrate between 0 to pi, and that would be actually pi r0, which is the length of the circular arc, times y bar of the circular arc. Okay, so essentially the r squared r0 squared comes out of the integration because it's a constant, and you are simply doing sine theta d theta between 0 to pi, and as we discussed earlier, this is simply 2. Okay, so the y bar for the circular arc is twice r0 squared divided by pi r0, so basically twice r0 by pi. Okay, and that expression is quite different from this one right here. Okay, so you can substitute this expression right here. Okay, but in the semester or in the class test, don't just use this expressions from mind. Okay, show these expressions. These are simple integrations you can do in a second. So just do that and derive it. Okay, so you don't have to be bothering about whether there is a correct expression or not. So with that you can get L times y2 bar, and finally you can get the total surface area, area of revolution plus twice this area. Acha. Uh, so I think with that you can pretty much do this. Uh, so for so this is the last problem that we need to look into, and I think by now you would be in a position to solve this one. So you need to get the surface area of revolution for this geometry. So basically it's a circular arc that is revolved around z-axis, but it's not an arc which is like this. Okay, it's an arc which is like this.
Sir,
Okay,
sorry to interrupt.
so
Sir,
sorry.
the answer to the last question is coming 2.42 into 10 to the power 5.
2.42 into 10 to the power 5 millimeter square,
Yeah.
the total area.
Yes, sir. Not, sir, total, not revolution area.
Acha, area of revolution. Okay.
Yes, sir.
Okay. So all you need to do, in addition to what I discussed, you need to make a correction for the distance from the distance of the center of the circle from the z-axis. So that also needs to be done. Okay, in that expression, just check if you have done that. Acha. So the thing is, in this case you are supposed to take x bar, and x bar okay, so the x is measured in this way. Okay. So the point is we just identified that for semicircular arc, and if you look carefully at the expression, you would also realize that that is also true for a quarter circular arc, that the centroid obviously lying on the straight line, which makes an intercept of 1:1, or a is a00a, and there it is lying on at a distance. So this distance is going to be, from the top, it is going to be how much did we say? Twice r0 by pi, so twice a by pi, right? Okay, and again you can show that by taking this one as a center. Okay, and taking the angles correspondingly, let's say theta measured from here and d theta and so on. So with that you can show that whatever this turns out to be. So if this is twice a by pi, so this is essentially a minus twice a by pi. Okay, x bar. And by the time you get the x bar, you don't need any further expression. You can simply use this to get the surface area of revolution. Okay, so here the only thing that you need to get is the surface area of revolution. Okay. Acha. So today we don't have enough time to discuss moment of inertia. But the point is, yes, of course, we can do that in the next class. but the point is that means we'll lose 1 day for that, and I'm just skeptical whether we would have sufficient time. So your session is dissolving on 7th of August, as I have been informed that your session is dissolving on 7th of August. Uh, is that true? Do you know about that?
No, sir.
Okay. So if that is not the case, then we would only be having 3 days to cover entire dynamics, and that would be impossible. Um and because there are just 9 of you right now present in the class, I'm not uh, tempted to begin a new topic today. So we'll leave it for the next class, but meanwhile, uh, practice all the problems that we did. তোমাদের কালকে কোনো এক্সাম আছে নাকি?
17 তারিখ স্যার, আজকে ছিল একটা।
Okay, so if you have no further questions, so we can stop here. And
স্যার
yes,
স্যার আমি